The Newton's first law of motion is law of inertia. And inertia means the inability of the object. And this inability is related to the change in present state of the object. Now imagine there is a mass m which is at rest. This mass is simply at rest. If you do not apply any force from any side, so imagine there is no force acting on this object, and here this force which I have drawn is not there. Or if there is a force like F, so if same force is applied in opposite direction, then what will happen? They both will cancel each other. In that case also, what happens? The net force is 0. So Newton's first law of motion, which is law of inertia, says that if the net force acting on an object is 0, then the object will not change its present state. It means every object wants to be in its initial state in absence of an external force. Now let me elaborate it. So we can say that an object can be in two situations. For example, it can be at rest or it can be in motion. So if an object is at rest, it wants to be at rest, and if the object is in motion, it wants to be in motion until and unless there is an unbalanced external force acting on that object. You can see that example in your day-to-day life. For example, the laptop which is kept on the table, it will always stay on the table until and unless you go and displace the object from its present position. Similarly, you can say the book kept on the shelves will remain always there until and unless an external force acts. Now Newton's second law. Newton's second law is law of force. It means this law gives relation between the force acting on an object, and the acceleration of the object. So imagine here is a football, right? And you slowly kick this football, then you will find that this ball will move slowly and it will come to rest after some time. Now if you increase this force, and let's say now you make this force 2F, then the ball will move faster compared to the first case, and now it will go a little more further. If you make this force now 2F additional, it means now the force becomes 4F. So 2F plus 2F, the force becomes 4F. In that case, this ball will move even more faster and it will cover longer distance. So what you can see is the more force you apply, the faster the ball will move. And this is what the Newton's second law is. So Newton's second law says that the more force you apply on an object, the greater will be its acceleration, right? The acceleration and force, they are directly proportional to each other. Now if I replace this proportionality sign, then I can write F is equal to mass of the object into the acceleration. This is the formula to calculate the force acting on an object based on its mass and acceleration. Now the unit of the force can be written as Newton, or you can write the unit by using this formula. Unit of mass is kg and unit of acceleration is meter second power minus 2. So the unit of force is kg meter second power minus 2. Now here is the Newton's third law. Newton's third law is the law of action and reaction. So imagine there are two balls, something like this, ball A and ball B. And ball A moves towards ball B with velocity v. So after some time, the ball A hits the ball B. When ball A hits the ball B, it applies some force on ball B. So the force applied by the ball A on ball B is, let's say, FA. In response to that, ball B will apply force on ball A. So the direction of FA was something like this, and this is FA, and the direction of FB will be something like this. It means FA is pointing towards the right side and FB is pointing towards the left side. So the ball B will also apply the force, and that force will be FB. Now, according to Newton's third law, the force applied by ball A will be is equal to the force applied by ball B, no matter what the size of ball A or ball B is. Even if the ball A is large and ball B is small, then also the force will be same. And that is what the Newton's third law says. And Newton's third law says that FA will be is equal to FB. And one more important thing here you need to add, FB will be opposite to FA. It means if FA is acting towards left, FB will act towards the right. It means if FA acts towards the right, FB will act towards the left. So this is the action and reaction law, and this is the formula for that. And if you combine these two, you will get FA plus FB is equal to 0. It means net force acting on the system is 0. Now you can find the examples of Newton's third law in many places, and whenever you may be watching the rockets taking the satellites into the space, there is the example of Newton's third law. The hot gases which create a cloud around the rocket, they are coming out with high pressure and high speed. So these gases are applying an action, and the action are the gases are moving downward. Now in response to that, the gases apply force on the rocket, and that force is upward. Now let's see how do we get that formula in Newton's second law, which is F is equal to ma. So consider there is an object of mass m which is moving with some initial velocity u. After some time, the mass of the object remains same, but its velocity becomes v. So let's say the time taken by the object for the change in velocity is delta t. You know, the mass into velocity gives us momentum. So this is the initial momentum because it's multiplied with initial velocity, which is u, and mass into final velocity will give us final momentum, pf. So if we write here, we can write change in momentum is how much? Pf minus p. P is here initial momentum. So delta P is equal to, we can write mv minus mu. Now this change in momentum is happening in certain time, and that time is how much? Delta t. So if we divide change in momentum by time, what we get here? We get an equation something like this: delta P by delta t is equal to mv minus mu by delta t. Now we can write it something like this, that delta P by delta t is equal to m v minus u by delta t. So what I'm doing here, I'm taking m common. So I can write now m into a. Why a? Because v minus u by delta t represents acceleration. What? Acceleration. So mass into acceleration is equal to delta p by delta t. And this delta p by delta t is called as rate of change of momentum. And let's write this rate of change of momentum as f. Then we will get f is equal to ma. And this is how we get the formula of Newton's second law.